Top Secret Sci-Operative Training Mission. Reading Passage The Quantum Model. Mission: Understand the differences between the quantum mechanical model and the Bohr model of the atom. Understand the organization of the quantum mechanical model. Tips: Remember to beam as you read through the passage below.
Hi, Dr. Joshi. Can you help me? My laser has been really unpredictable since I started using helium gas.
What seems to be the problem?
I used the same math equations that are used for the hydrogen model to predict the colors my laser would make, but it was totally wrong.
Scientists are always adapting as we learn more and have access to new technology. When the mathematics of the Bohr model are applied to atoms with more than one electron, like the helium in your laser, the model no longer correctly predicts emission spectra lines. This is why your laser is producing different colors than expected. It is also why the quantum mechanical model of the atom was developed. The quantum model further mathematically defines the atom to explain the electron behavior for all elements. Emission spectrum of hydrogen and helium. The top bar with lines is the emission spectrum for hydrogen that matches what Bohr predicted. The bottom spectrum for helium is not predicted with Bohr's mathematical calculations.
Is there something different about electrons when you add more?
Electrons are still the same, no matter how many you add. What is different is how different models depict their behavior. In the quantum model, electrons are not just considered a particle, because they also have some properties of waves. This is known as the wave-particle duality, because the electrons exhibit some behaviors of both particles and waves. When electrons act more like particles, we can determine how fast they are moving. When they act more like waves, we can determine their location. Unfortunately, we can't know both at the same time, so most people focus on predicting the location of electrons. This prediction is based on probability laws, which are determined by using mathematical functions associated with waves.
If the quantum model uses probability laws to predict the location of electrons, then we do not know their exact location, right? How do we draw this on the model?
You've seen that electrons are located within an electron energy level or shell on the Bohr model. But in the quantum model, those energy levels are no longer shown as rings. Instead, within each energy level, there are areas with specific shapes called orbitals. Orbitals are three-dimensional regions where an electron has a high probability of being found. There are four orbital shapes: S, P, D, and F, which you can see on the diagram. Orbital shapes. The first orbital shape on the left is S. The second orbital shape is P. The D orbital shape is next, and the F orbital is last.
Those don't look that complicated, Dr. Joshi. I could draw those.
Well, Nikole, there's a bit more to it. Most energy levels contain multiple orbitals and they overlap. There can even be multiple orbitals of the same shape in all three dimensions. The simplest example is when one s orbital and three p orbitals overlap.
That's pretty amazing. I don't understand though. Why are there three p orbitals in the picture?
In order to understand why there are three p orbitals, you need to understand the concept of a sublevel. A sublevel forms when all of the orbitals with the same shape within an energy level are drawn in three dimensions. A p sublevel always contains three individual p orbitals in all three dimensions that come together. When the one s orbital, which makes an s sublevel, and the three p orbitals, which make a p sublevel, of the same energy combine together, this creates a complete energy level. As you can see, the D and F sublevels are very complicated and almost impossible to draw. In fact, it becomes so complicated that some people call the quantum model the cloud model, because the areas of probability can't be clearly drawn. The top row shows the orbital shapes that you saw before. The bottom row shows the sublevel, which merges together all the orbitals with the same shape within an energy level.
If these are so complicated to draw, how can people know where electrons are located around the nucleus?
Scientists have come up with a different way to communicate the location of electrons. They use orbital diagrams, which are pictorial descriptions of the electrons in an atom that show where electrons are most likely found. The numbers on the diagram, such as 3, denote the energy level or shell where the orbital is found. This energy level is synonymous with the rings on the Bohr model. The orbital, where specific electrons move around the nucleus within a sublevel, is depicted as a box. The energy levels on the Bohr model are the rings. In orbital diagrams, the energy levels are the numbers. Within the energy levels are the sublevels like S and P. Remember that sublevels are often made of multiple orbitals, so each orbital is a box on the diagram.
This is a lot easier to draw than those complicated sublevels. But shouldn't the diagram have S, P, D, and F sublevels on each energy level?
The periodic table can help us determine which sublevels are found within each energy level. The energy level number is equal to the period, which are the horizontal rows that are numbered from 1 to 7. Different sections of the periodic table also match with the 4 sublevels. If you look at each period, you can then count how many different sublevels are found within that energy level. The period numbers are on the left side and equal the energy levels. The S, P, D, and F sublevels are in 4 sections on the periodic table. Sometimes you'll see helium, which has the symbol He, moved to the left beside hydrogen, which has the symbol H, to better show the S sublevel.
That's really convenient how the sublevels are organized into orderly sections on the periodic table. It makes it so easy to see. How do all the orbitals within a sublevel fit into this?
We know as we go through the periodic table, each element has one more electron. However, each individual orbital can hold only 2 electrons. This means that you have to count how many electrons are in each sublevel in order to determine how many orbitals are within a sublevel.
The S sublevel seems to always have 2 elements. I think that means there are always 2 electrons in an S sublevel and only 1 orbital. Is that right?
That is correct, Nikole. That is also why there is only 1 box drawn in an orbital diagram for the S sublevels, because there is only 1 orbital. Can you tell me how many orbitals are within a P sublevel?
On the periodic table, there are always 6 elements in a P sublevel. So that means that there are 6 electrons and 3 orbitals in a P sublevel. So the P sublevel gets 3 boxes.
Correct! The pattern continues with the 2 other sublevels. Best of all, the quantum mechanical model can be applied to all atoms, not just hydrogen.
Thanks for telling all about this, Dr. Joshi. I think my laser will make a lot more sense using the quantum mechanical model.
Make connections. In each box below, write a connection between the text you just read and either your prior knowledge or something in your life. Reading comprehension questions. The quantum model. Number 1. Label each of the shapes below with the correct orbital designation. Example, S orbital. Number 2. What is wave-particle duality? Explain how this was used to develop the quantum model. Number 3. In the Bohr model, rings are drawn to communicate the location of electrons. For the quantum mechanical model, Why are orbital diagrams used to communicate the location of electrons rather than the model itself? Number 4. Fill in the graphic organizer with the terms below, then add a definition for each term in its section. Lowest level of organizer should be the term that includes the largest category, and the top should be the term with the smallest or most specific categorization. The three terms are sublevel, energy levels, and orbitals. Number 5. While the Bohr model does not correctly predict the behavior of atoms with multiple electrons, it does correctly predict the number of electrons in the first and second energy levels. Using the periodic table, explain why there are a total of 2 electrons in the first energy level and a total of 8 electrons in the second energy level. In your answer, make sure to include the terms energy level, sublevel, and orbital. Number 6. Determine the number of orbitals in the d and f sublevels and provide an explanation for how you found each value. Number 7. Summarize the overall main idea of the passage. Challenge. Using the periodic table, predict the order of the energy levels and sublevels until reaching 5p. Example: 1s, 2s, 2p. Hint: the D sublevel begins with 3D instead of 4D.